Hello everyone, my name is Stephen Joy Chilmula and welcome to Stephen Explains. So today we are going to learn about a wonderful chapter called sets. Now before starting the chapter, there is some basic info which you need to know, which includes symbols with their meanings respectively, such as n for natural numbers, z for integers and so on. Now starting the chapter with the definition itself, what is a set? A set is a collection of well-defined objects which are distinct and distinguishable. Notation of a set. For example, there are two sets, set A and set B, which are denoted by capital letters like A, B, C or anything, and the entries within the bracket are known as the elements of set. Cardinal number of a set, which means the number of elements present in a particular set. It is denoted by number of elements in set X, where n equals number of elements and X equals a particular set. For this example, the number of elements in set A are 4, and for this example, the number of elements in set B are 6. Representation of sets. Starting with the first one, rooster method. In this method, a set is described by listing all the elements separated by commas within brackets. For example, set A equals 2, 3, 5, 7. So here these elements are separated using commas within these brackets. And the second one, set builder method. In this method, a set is described by characterizing property. Now taking the same example from rooster method, in set builder method, we write it as set A equals x is such that x is a prime number, comma, x is less than 10. It might be confusing, but here we are describing the characteristics of the elements. We mentioned x is such that x is a prime number, which means that the value could be from 2, 3, 5, 7 and so on. And we also mentioned that x is less than 10. So the prime numbers which are less than 10 are only 2, 3, 5 and 7. If we see the symbols such as colon or pole if we want to use, they mean is such that. And the Greek symbol epsilon means belongs to. Generally, for a set, you cannot repeat elements. For example, x equals x is such that x is a letter of school. In rooster method, you cannot write x equals school because here O is repeating twice. The correct way to write is x equals schol in rooster method. You can write elements in any order. Using the same example, you can write it in arranged, reversed, mixed or any order as you wish. Types of sets. There are a total of 9 types of sets, starting with the first one, finite set, which means a set whose elements are countable or can be listed. From the example, A equals set of English alphabets, B equals set of subscribers. So these are the sets whose elements can be counted. And the second one, infinite set, a set whose elements are countable or cannot be listed. For example, x equals x is such that x belongs to natural numbers. In rooster form, if we write, it starts with 1, 2, 3 and so on till the point where the numbers are uncountable. Third one, singleton set, which means a set consisting of a single element. From the example, we know that x belongs to natural numbers and it lies between 1 and 3, which means there is only one value, 2, which can be represented in rooster form. In the set X or any singleton set, the number of elements would always be 1. Fourth one, null set. A set is said to be empty, void or null set if it has no element in it. It is denoted by the symbol phi. For example, y equals x is such that x equals -1 and x belongs to natural numbers. We know that in natural numbers, there are no negative numbers. So in rooster form, we can write it as empty brackets or the symbol phi. Fifth one, equivalent set. Two finite sets A and B are equivalent if number of elements in set A is equal to the number of elements in set B. From the example, there are two sets and in both of the sets there are equal number of elements. So we can write it as the number of elements in set S is equal to the number of elements in set T. Sixth one, equal set. Two sets A and B are said to be equal if every element of A is present in B and every element of B is present in A. From the example, there are two sets E and P and both of them have the same elements present. So we can write it as E equals to P. Looking at another example, both the sets H and N do not have the same elements. So they can be written as H is not equal to N. Seventh one, universal set. It is a set which includes all the sets under consideration and it is denoted by U. From the example, if A equals 1, 2, 3, B equals 4, 5, 6 and C equals 7, 8, then U, which includes from 1 to 8, is taken as a universal set for ABC because U contains all the elements which are present in the set A, B and C and hence becoming the universal set for the sets A, B and C. Eighth one, disjoint set. Sets A and B are said to be disjoint if A and B have no elements in common. For example, from the set D and D, there are no elements in common. And for the set F and G, here there are no elements in common as this one contains odd numbers and this one contains even numbers. And the last type of set, complementary set. Complementary set of set A is a set containing all the elements of universal set which are not in set A. It is denoted by A bar, A to the exponent C or A apostrophe. It might be confusing, but I'll tell you clearly. So A bar in the form of set builder method can be represented as X is such that X belongs to universal set, comma, X does not belong to A. So basically A bar equals U minus A, which means we are going to remove the elements of set A from the universal set. For example, if universal set equals 1 to 50 and the set A equals 1 to 5, so the complement of A would be U minus A. So we are going to remove the elements of A from the elements of universal set and we are going to write it as 6 to 50. And there's also an interesting note. All disjoint sets are not complementary sets, but all complementary sets are disjoint sets. We learned about sets, now let us see about subsets. A set A is said to be a subset of B if all the elements of A are present in B. It is denoted by A subset of B. So we can write it as A is a subset of B. Now looking at other example, here set C has the alphabets ABC and set D has the alphabets CDEF. So here one element is common, that is the alphabet C. But in order to be a subset, all the elements of one set should be present in another set. So we can write it as C is not a subset of D. Number of subsets. Consider a set A containing n elements. To find the total number of subsets, we should use the formula total number of subsets of set A equals 2 to the power of n, where n equals number of elements. Now looking at this question, we are required to find the number of subsets for the set A equals 1 to 3. As we have discussed earlier, we are going to use the formula total number of subsets equals 2 to the power of n. Since there are 3 elements, it is going to be 2 to the power of 3, which is going to be 8. Now on solving, you are going to write the subsets separately. On writing the subsets, you are going to write the elements in sets, starting with set 1, set 2, set 3, set 1, 2, set 1, 3, set 2, 3, set 1, 2, 3 and the empty set 5, which are going to be a total of 8 subsets as per the formula. Here's an important note that 5 is a subset of every set. Now comes the last topic, proper subset. As we have discussed the earlier question, to find the number of subsets, we are going to use 2 to the power of n. But if you observe, here one thing is common. So in proper subset, we are going to exclude this thing. So the formula for proper subset is 2 to the power of n minus 1 and that one thing is going to be this. So on writing proper subsets, it's going to be all the elements as it is without the element 1 to 3 which is also present in the question. And that's it for the video. Thanking you. There are still a lot of topics to be covered such as Venn diagram and many more, and I will be covering all of them in my future videos. Until then, see you in the next video.